This is the continuation, or part 2, of the 6.03 review. So table salt or sodium chloride, NaCl, can be produced by reacting sodium metal, Na, with chlorine gas, Cl2, as shown in the equation below. 2 atoms of Na plus 1 molecule of Cl2, meaning there's 2 chlorines bonded together into 1 molecule, yields 2 molecules of NaCl. If 100 atoms of sodium react with 48 molecules of chlorine gas, how many formula units of NaCl would be produced? So the first thing you want to do is look at the ratio. So I need 2 NAs for every 1 chlorine molecule to produce 2 molecules of NaCl. So it says that I have 100 atoms of sodium. All right, so if I have 100 atoms of sodium, that produces 100 molecules of NaCl. Because if we look back up here, our ratio is 2, 1, 2. So if I have 100 there, 100 blank 100. 2, 1, 2, 100 blank 100. So now I need to know, all right, well, how much chlorine would I need? Well, it's half as much, right? So I have 2, 1, 2. So I need half as much. So it'd be 100, and then 50, and then 100. I can also check to see that my equation is balanced. I have 100 sodiums on the left, 100 sodiums on the right. I have 50 times 2, or 100 chlorines on the left, and when I distribute, 100 chlorines on the left. All right, well, do I have enough chlorines? Well, no, I only have 48. So chlorine is my what? My limiting reactant. So therefore, I'm going to need to make it again. This time I have 48 of the chlorines. All right, so remember my original ratio was 2, 1, 2. So if I have 48 chlorines, how many sodiums will I have? Well, I'll have twice as many. So 46 times 2 is 96. And how many NaCl's will I have? Well, it's the same amount as NAs, and we balance out our equation, and I get 96. I toggled back to our Chemistry's Problem Solution book, and it has that same thing written out. Recall relevant information. A reaction consumes all of the reactants only if they are present in the correct ratio. The coefficients in the chemical equation give the ratio of the reactants needed to produce the product. Step 2, examine the equation. According to the chemical reaction, 2 atoms of sodium are required to completely react with 1 molecule of chlorine. The result of this reaction is the formation of 2 molecules, or formula units, of NaCl. And then solve. For all 100 atoms of sodium to be completely reacted with chlorine, we'd have to take 100 divided by 2 equals 50 molecules of chlorine would be required. However, only 48 molecules are present. Therefore, all the chlorine will be consumed, but not all the sodium will be consumed. To react with 48 molecules of chlorine, 48 times 2 equals 96 atoms of sodium are required. This reaction will also then produce 98 formula units of sodium chloride with 4 atoms of sodium left over. Because I had 100, I only used up 96 of them. Okay, that weird beep was my school phone. So we'll continue on here. The big thing to remember is that you have to remember your ratio. Look back at your original balanced equation, 2 to 1 to 2, and that's what you're going to use with your numbers. All right, so then they give you 2 problems to do. They said to do problems 1 and problem 2. Now, you have the answer keys to this. Your answer keys are in the student guide. So when you click on the student guide and open that, here are the links you will use to find the answers. Here's question 1. Ammonia's chemical formula is NH3. How many atoms of nitrogen and hydrogen are required to form a single molecule of this compound? So we simply look at our subscripts, and for these, if you forget, always think of one that you know. You know H2O. You know that means there's 2 hydrogens, and you know that there's 1 oxygen. All right, So N with no subscripts means there's how many? 1. And H3 means there's how many hydrogens? 3. All right, so this is about as hard as it gets. If the formula is Al2 parentheses SO4 parentheses 3. So how many atoms of aluminum, sulfur, and oxygen are required to form a single molecule of this compound? So how many aluminums are there? There's 2. How many sulfurs are there? Now don't forget, you have to distribute this 3. So how many sulfurs? 3. And how many oxygens? Again, you need to distribute. 3 times 4 is 12. And here's question number 2. It says hydrogen chloride, or HCl, can form from hydrogen gas, H2, and chlorine gas, Cl2, according to the equation below. H2 plus Cl2 yields 2 molecules of HCl. If 500 molecules of H2 react with 400 molecules of Cl2, how many formula units of HCl will be produced? All right, now look at your equation. I have a ratio of 1 to 1 to 2. So which one do I not have enough of? Well, since they're both 1s, that means I need equal parts. So which one is there not enough of? There's not enough chlorine. So again, look at your coefficients for this ratio, and you will see you need 1 H2 and 1 Cl2 for every how many HCl's? 2. It says you have 500 H2 and 400 Cl2s. Which one do you have too much of? The H2. Therefore, which one do you have to use for your story problem because it will run out first? You have to use the Cl2. So substitute. If I have 400 Cl2s, I have how many H2s? Well, for every 1, I have 1. Therefore, I have 400 total. Okay, and I can put that down in my equation. So I have to have 400. Okay, and how many total HCl's will that make? Well, go back up here. For every one of these and one of these, I have how many? 2, or twice as many. So what has to be my coefficient to balance my equation? I can also just balance it and say, oh look, I have 800 on both sides. Therefore, my answer has to be 800 of the HCl's to be balanced. We're now going back to our problems and solution book and doing the second part, which is problem set 46, mole number relationships. You can use Avogadro's number to calculate the number of particles in a given amount of a sample and the amount of a substance from a given amount of particles. Atoms and molecules are too small to count by usual means. Even the smallest visible object contains hundreds of billions of atoms. Therefore, chemists use a specific unit, the mole, abbreviated MOL, to describe the number of particles in a sample of a substance. The mole is a way of counting any type of particle, atom, molecule, ion, or formula unit. 1 mole of a substance is defined as the amount of that substance with the same number of particles as there are in 12 grams of carbon-12. That number is 6.02 times 10 to the 23rd. Just as 1 dozen donuts means 12 donuts, 1 mole of a substance means 6.02 times 10 to the 23rd particles of that substance. This experimentally determines the number of particles in a mole is called Avogadro's number. Avogadro's number can be used to convert between the number of moles of a substance and the number of particles in a sample of that substance. Objective: use Avogadro's number to convert between moles and number of particles. Remember, Avogadro's number is 6.02 times 10 to the 23rd. Sometimes they abbreviate it as that, sometimes they say 6.022. So, depending which one they have you use, just use that one. 1 mole of a substance contains Avogadro's number of basic particles of the substance. The chemical formula for a substance shows the atoms that make up a basic particle of the substance. The formula unit is the basic particle of ionic compounds. The molecule is the basic particle of covalent compounds and molecular elements. The atom is the basic particle of non-molecular elements. Calculate the number of particles in a given amount of substance. Caffeine, which the chemical formula is C8H10N4O2, is a drug that is naturally produced in the leaves and seeds of many plants. How many molecules of caffeine are in 2.31 moles of caffeine? So strategize. 1 mole of caffeine is 6.02 times 10 to the 23rd molecules of caffeine. Use a conversion factor or fraction to calculate the number of molecules of caffeine in 2.31 moles. All right, so start out with what they give you. They gave you 2.31 moles of caffeine, and then we do our conversion fraction. Now remember from our previous lessons that the top and bottom have to equal each other, but different units. So 1 mole of caffeine is the same as 6.02 times 10 to the 23rd molecules of caffeine. I have to put moles on the bottom. Why? So that it cancels with what I started with. Okay, so sometimes moles is on top, sometimes on the bottom. In this case, it's on the bottom, so it cancels with the original unit. Then I multiplied 2.31 times 6.02 times 10 to the 23rd, and my answer is 1.39 times 10 to the 24th molecules of caffeine. Therefore, 2.31 moles of caffeine contains 1.39 times 10 to the 24 molecules of caffeine. Please put it in your calculator and make sure you know how to do that. If you don't, ask me for help. Calculate the number of moles in a given number of particles. Automobile airbags inflate when sodium azide, NaN3, rapidly decomposes to form sodium and nitrogen gas. If a particular sample of NaN3 contains 9.2 times 10 to the 29 formula units of NaN3, how many moles of NaN3 are in the sample? Start with what you know. So what were you given in this problem? You were given 9.2 times 10 to the 29. Write that down first. Formula units of NaN3. Yes, write the whole thing. Because what has to go on the bottom of your next fraction? Formula units of NaN3. So they cancel. And I know that there's 6.02 times 10 to the 23rd of them in 1 mole. So then in your calculator, you're going to put 9.2 times 10 to the 29 times 1 divided by 6.02 times 10 to the 23rd, and you'll get your answer saying, therefore the sample contains 1.53 times 10 to the 6 moles of NaN3. Again, put it in your calculator. Make sure you get that answer. Now, if you are not quite sure what that looks like, so that 6 means that you need to move your decimal place to the right 6 times. And so in your calculator, chances are it will just look like 1,530,000. All right, so now for this one, you need to be doing questions 1, 2, and 3. All right, and I have a couple that I have on my whiteboard that we're actually going to go over first. So the first one says, which one of these has the greatest mass? And I just copied it from my periodic table. So is it carbon, nitrogen, or oxygen? I could have also written it this way. Which has the greatest mass? 12 carbon, 14 nitrogen, and 16 oxygen. So any of those would be a correct way of doing it, either the picture or writing it. And which one has the greatest mass? And it is oxygen. So oxygen has the biggest mass number, meaning the most protons and the most neutrons. And we will finish the rest of this lesson in the next part of the recording.